Welcome to our channel. In the last session, we discussed insertion operation in circular linked list. What are the different types of insertions we done? Insertion at the beginning of the circular linked list, at the end of the circular linked list, and at any given position. These are the three possibilities of insertion we had done. Anyway, you know the concept of circular linked list. In the list, the last node always points to the first node. That means the address of the last node is the starting node. Now, in this session, we are moving into deletion operation in the circular linked list. Again, we are doing deletion in three ways. Delete an element at the beginning of the list. Okay, what is the first condition? To delete an element, first, we are checking whether the list is empty or which consists of at least one element. If head is equal to null means till now there is no element in the linked list. Simply deletion is not possible. Deletion is not possible. Suppose if it has one element, what is the condition? The starting node is head dot next is equal to, in the normal linked list, head dot next is equal to null means only one node. But here this is the diagram of single node. This is head. The next field again refers to same. So head dot next is equal to head means only one node is available. Simply we are printing the data at that node and we are making head is equal to null. That means we are deleting that node. Clear? Now coming to the main important case means if you have more than one element is available. Suppose assume this is the linked list. Now what is your aim? You need to delete head node. Simple logic. In the normal case, simply we are removing head. Head is equal to head dot next. That is fine. But in the case of circular linked list, always the last node points to the first node. For that reason, first what is your aim? You need to identify the position of the last node. For that, I am using one temporary variable. So temp is equal to head. This is my temp. Now we are doing some iteration. By each and every iteration, what is my aim? To reach the end node. So I am repeating one loop while temp dot next. What is the end node condition? In the end node, the next field consists of head. If the temp dot next not equal to head means observe. Initially temp is equal to this one. This next not equal to head. Yes, not equal to head. Now temp points to next position. So temp is equal to temp dot next. In the next iteration, again, temp dot next not equal to null, condition true. Temp is equal to temp dot next. In the next iteration, temp dot next not equal to head, condition true. Now temp is equal to temp dot next. In the next iteration, temp dot next not equal to head, condition false. So we stop the process. That means right now I am at this position. Now what is your aim? Your aim is first I am print the data. Whatever the data available at the head, I am printing the data. Now your aim is the temp needs to point this position. But how this is the position? This position is actually this next. Now temp dot next is equal to this one, where this address is available in head dot next. Now you got the point. So temp dot next is equal to head dot next, and then head points to this one. So head is equal to head dot next. Okay, or else you can do in other fashion also. First I am moving head is equal to head dot next. That is right now my head is this position, and immediately temp dot next is equal to head. If you first to move the head, then directly. Otherwise, first to assign to next and then increment the head. This is delete a node at the beginning of the linked list. Okay, especially in circular linked list. Now, this is the program we done in the last insertion. Coming to after insertion, here I am doing deletion operations. Do the deletion public void delete begin. Okay, within this one, what is the first step? If head is equal to null, means there is no element. System dot out dot println. Simply I display one message. List is empty. If the list is empty, means no element is available. Else, if what is the condition? Only one node. Head dot next is equal to head. What is the meaning? Head dot next is equal to head means one node is available. Then what I am doing? System dot out dot println. I am printing the data. Suppose deleted value is plus head dot data. After that, once the node value is printed, now head is equal to null. Close this else if. Fine. Now coming to else block. What is the else block? More than one node is existed. In that situation, else create one temporary node. Initially, it points to head. Now, repeat one loop until reaching of last position. The last position next to field is head. So, until the next to field not equal to head, I am repeating the temp. Temp is equal to temp dot next. Fine. Close the while loop. After this, print the data. Whatever the data you have, simply print the data, the deleted, and then update the pointer. So temp dot next is equal to head dot next. Okay. After that, head is equal to head dot next. This is else case. This is the concept of delete a node at the beginning. Save. Now move to delete a node. What is my second operation? Delete a node at the end of the linked list. So again the first condition, if head is equal to null means no element, head dot next is equal to head means only one element. That is common. Now more than one element is existed. What is the situation? Yes, this is the head node. Now, what I am doing? Your aim is you need to delete this node. So, once this node is deleted, now this node becomes the last node. Yes or no? After deletion of this node becomes the last node, and this node address is head. This is your aim. That means here you need two pointers. One pointer points to the last node, another pointer points to the before node of the deleted node. As usual, first I am assuming one node temp, which points to head. This is the temp node. Anyway, I am using one more pointer. Initially, that pointer value is equal to null. Now, what is your aim? Reaching the end. So here I am writing a loop like this while temp dot next is not equal to head. You know the logic. This is the condition. Within this one, what is your step? General, our step is temp is equal to temp dot next. By this, we are reaching the end. By this, temp is this position. But my aim is you need to store the position. For that, before updating the temp, I am storing the previous. Observe carefully. Initially, temp is equal to head, ptr is equal to null. Yes, temp dot next not equal to null. What I am doing? ptr is equal to temp. Now, this is also ptr. Next, temp is equal to temp dot next. Now, this becomes temp. Now, you got it? before moving the temp to the next position, I am storing the address of previous value. In the next iteration, temp dot next not equal to null. Yes, sorry, not equal to head. PTR is equal to temp. Now, this is PTR. Temp is equal to temp dot next. This is temp. In the next iteration, again it is not equal to head. PTR is equal to temp and temp is equal to temp dot next. In the next iteration, temp dot next not equal to head, the condition fail. So that means we are reached the end of what is happened. Simply print temp dot data and then simple logic. PTR dot next is equal to head. Automatically this link is formed. And if you want, you can make temp is equal to null. I am completely delete the node. You got the points? The only additional point is you need to store the address of last to before node. Okay. Now move to the program. Here most of the logic is same. So I am just to copy that logic. Copy, paste. Okay. Now mark this one as delete end. Here the first condition okay, second condition is okay. In the third condition, what I am doing? Node PTR. Initially the value is null. Even though you are not giving, not a problem. Now before updating the temp, I am using this one. PTR is equal to temp. Now so once I reach the end, where the data is available, at the temp node, my data is available and ptr dot next is equal to head. And if you want, you can mark temp is equal to null. Or even though through garbage collection, the unreferenced objects are automatically removed. Clear? PTR dot is equal to next, or else here you can write like this also. PTR dot next is equal to temp dot next. You got it? Before deletion, you can write PTR dot next is equal to temp dot next. Both are same. Clear? This is deleting a node at the end of the linked list. Now move to the last case, deleting a node at the specific position. Okay, at the specific position, the first step. If head is equal to null means simply the list is empty, not possible to delete. Whether it is the first position or second position, if there is no element means no need to delete. Yes. Now we are checking one by one. Suppose if position is equal to 0 means instead of writing entire for loop checking all the cases, position is equal to 0 means simply delete a node at the beginning. Obviously, call the function, we are deleting the node. Obviously, we are calling the function and delete a node at the beginning. Now, else means delete a node at a specific position. Now, observe how we are writing the logic, and the last node always points to the first node, and this is the head node, position 0, 1, 2, 3, 4. Suppose given some position, suppose delete a node at position number 2. Delete a node at position number 2. Now what I am doing? As usual, I assume the first node as the head node. Okay. Temp is equal to head. Understand the logic carefully. Temp is equal to head. Now I repeat a loop. What is your aim? You need to delete this node. So for repeat one loop, I is equal to 0, I less than position, I plus plus. Here, what is the logic? In the previous case, if you are deleting a node at the end, you are storing the previous also. Similarly, here also delete a node at a specific position. I am using the logic same. PTR is equal to temp and temp is equal to temp dot next. Now, anyway, observe carefully. First, I is equal to 0. I less than, what is my position I given? 2. See, PTR is equal to temp. Now, this is PTR. Temp is equal to temp dot next. Now, this is temp. In the next, I plus plus, I value is equal to 1, PTR is equal to temp, this is PTR, and temp is equal to temp dot next. You got the point? This is the basic logic. This is the basic logic. Right now, this one. Now you know the remaining logic. What is the logic? This name is PTR, this name is temp. Simply, you need to remove this node and form this link. How? Where the link? PTR dot next. Actually, what is the PTR dot next temp? Now, PTR dot next is equal to temp dot next. Automatically, this link is established. You got the point? Now, this is fine. But in this, we have some additional cases you need to consider. What are the cases? For example, I given the position number 6. Delete a node at position number 6. So I is equal to 0. This is PTR and this is temp and so on. Here my loop is up to 4 only. After 5, there is no temp. Sorry, there is no element. Now, where the temp points to? You got the point? While moving, whenever temp is equal to head, here, after this, whenever temp moves to the next position and whenever temp is equal to head means my position is not at all reached. You got it? My position is not reached. Why? Here, first time temp is this one, temp dot next. This is 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 temp. Now, temp dot next, again it moves to the head node, but there is no position number 5, no position number 6. So each and every time you need to check this condition. If this condition means it is not possible to delete the node. Now, how we are coming out of the loop? Once we reach the corresponding position, that is one possible case, or else if my position is not available, that is another case. For that, we are using one flag variable to check whether we are coming out of the loop because of this condition or because of this condition. If you come because of this condition means the position is available, you are doing. Otherwise, it is not possible to delete an element. Now, we will write down that logic. This is a delete end, delete begin. Now, I will write down the logic public void delete position. Here you need to give some position. Okay, fine. Within this position, first to create the temporary node temp comma PTR. Okay, what is the first case? If head is equal to null means the list is empty. As usual, the same condition, the list is empty. It is not possible to delete. Else, open the else and then I am closing the else. Within this else, what is the first case? If position is equal to 0 means we are deleting a node at the beginning. Simply call the method delete beginning. Automatically it calls the method. Now, else, for this else you are doing all your operation. Okay. Here I am using one flag variable. Just now we understand. I am using one flag variable, whether you come out of the loop because of availability of position or not availability of position. Now, the first node is pointed by temp node. Next to my aim is reach to the position for int I is equal to 0. I less than position I plus plus. Within the loop, what I am doing? PTR is equal to temp and temp is equal to temp dot next. Fine. So while moving parallelly, we are checking the condition. What is the condition? If temp is equal to head mean temp is equal to head means our position is not available. Got it? Simply print one message system dot out dot println position not available. Fine. Immediately update the flag variable. Flag is equal to 0 and then break comes out of the loop. The position is not at all available. No need to check the remaining cases also. Okay. Break. And then comes out of the for loop also. Once we are coming out of the for loop, next to your aim is check. Next to your aim is check. If flag is equal to 1 means we are coming out of the loop because of the availability of the position. Immediately what you are doing? PTR dot next is equal to temp dot next and print the value at temp dot data. Simply print temp dot data value. Okay, this is the way you are writing the logic. After that, so simply after inserting ob dot delete begin, call one time ob dot delete end. Okay, first I am doing these two operations. Go to the command prompt. We already executed. These are the elements in first after deletion begin. So just one error, illegal start of expression. So observe where is the error? ob dot display, public void display. Yes. So head dot next is equal to head. Here what you need to write? Here head dot next is double equal to head. Head dot next is double equal to head. Check where it is. Here this is okay. Here this one. Clear? Like this, it is very easy to rectify those errors. Double equal. Save. Again compile the program. Now, ptr dot next is equal to temp dot next. ptr might not have been initialized. Where observe delete at the end, ptr is equal to null. This is fine. Here, this one initially mark ptr is equal to null. Now got it? Observe 30, 20, 310. First deleted is 30 and then deleted is 200. Deleted at the beginning, deleted at the end. Now, what I am doing? Instead of these two, I am writing only one thing. Delete at position of some 3. Okay. After that, I am calling ob dot display. Save and run. Observe 30, 20, 300, 100, 200. This is my list. Deleted at position number 3. 0 position, first position, second position, third position. At position number 3, 10 is available. Position number 3, 10 is available. Suppose here I given some position number 9. Check 9 position is not at all available. See, 9 position is not available. So simply we displayed the message position is not available. This is the deletion operation in circular linked list. Okay, now you understand how do you insert an element and delete an element in the circular linked list. Thank you.